Okay, in this video we're going to be looking at reconnecting a supply from Y to delta. So it's very important if you come across these type of questions where it's reconnecting that you make note, is this the supply or is this the load that we are reconnecting? They yield very different results. So let's have a look. If we're looking at a supply, we're looking at the 3 coils on a 3-phase generator or the secondary of a 3-phase transformer. In this case, or in either case, we'd have a relative motion between these conductors or these coils of wire and a moving magnetic field. So the magnetic field would cut across these coils and induce a voltage. Each coil in this case produces a voltage of 120 volts, and due to its gauge size is restricted to a maximum of 20 amps. So we can only pull 20 amps of current through each coil before this transformer could potentially overheat or generator. So let's compare that if we connect these 3 coils in Y versus these 3 same coils connected in delta and see what the differences are. Over on the Y, we know that we are going to induce a voltage of 120 volts on each one of these coils. That will be our phase voltage. So our phase voltage is 120 volts. To calculate line voltage on a Y circuit, we can use the formula V line equals V phase times square root 3. That's 120 volts times root 3. It comes to 208 volts. Approximately 208. I of the phase, well, that's that maximum current that's allowed to flow through here. So the I phase is going to be equal to 20 amps. Because in Y there's only one path for that current to flow through these coils, it must come out on the line conductor. And there's only one path, so it's the same value. I line is equal to I phase. I line is 20 amps. If I compare that to the delta connection, well, the phase voltage is the voltage generated across each coil, so it's still 120 volts. We know in delta, if the phase voltage is 120, well, that is going to be the output line voltage as well. V line is also equal to 120. V line is the same as V phase. So 120 volts. The current in the phase is also given. The maximum current that can go through here is 20 amps. We know that the line current is a contribution of 2 of the phases, and therefore we can use for balanced circuits, we have this formula, and we can use it for this application as well. I phase times root 3. So 20 amps times the square root of 3 comes to approximately 34.6 amps. Alright, let's make a chart and compare the values. So the phase voltage on the Y supply is 120, and it's the same on the delta. That's what's induced on it. So no real change at all in the phase voltage. The line voltage we see is root 3 higher than the phase, so that gives us 208 when we're looking at it in Y. Over in delta, V line and V phase are the same value. So what's the difference? Well, it's root 3 less, or divided by root 3, difference when it goes to delta. We only have 120 volts. The phase current is 20 amps in Y, and that's the same as it would be in delta, 20 amps. No change at all. Well, in Y, line current is the same as phase current. So we've got 20 amps. But when we compare it to delta, line current is root 3 higher than phase current. So, when comparing the two values, 20 amps to 34.6 amps, we'd see it has a difference of root 3. So the line current would be only root 3 higher in delta than in Y. Hopefully this helps. We'll see you on the next flick.